Okay, students, so this is once again exam 3 review. We are doing number 7A. So I am going to follow once again the PowerPoint, the steps for balancing redox reactions. It is slide number 10 on the PowerPoint. So assigning oxidation states. This one, if anyone remembers, you have to assign hydrogen before you do oxygen. So hydrogen is +1. We have 2 of them, so we're at overall +2 charge. We have 2 oxygens here, so this oxygen is going to be a -2 overall because we need this whole thing to equal 0. So then this 1 oxygen would just be -1. So we're at -1 for this oxygen. That's weird. Normally we do a -2 for oxygen, but in this case with hydrogen peroxide we have a -1. So let's keep looking. Oxygen, we're going to do first, so that's -2. We have 2 of them, so we're at -4, so this chlorine must be +4. Once again, over here, this is -2. We got 2, -4. Overall, it has to equal -1, so this chlorine must be a +3. This oxygen is going to be 0, right? It's a standard free element. So let's look. Well, we know our chlorine ones go together, right? So that must mean this hydrogen peroxide must go with this oxygen. So let's look. This oxygen went from a -1 to a 0. Okay, its charge changed from a -1 to a 0. So it must have lost an electron, right? Electrons are negative. It lost an electron. It lost 1 electron. Okay, so it was oxidized. Our chlorine went from a +4 to a +3. So it gained, right, 1 electron. So it was reduced. So we did step 1, assigning what was oxidized, what was reduced, so we can write our half reactions. So our oxidation is going to be, right, our H2O2 is going to yield O2, right? H2O2, we said was oxidized to give us O2. How many electrons did we say? Well, we said it lost 1 electron. So our electron is going to go on the right. So there's going to be 1 electron over here. For our reduction reaction, make sure you can see everything. Our reduction reaction is going to be the ClO2 yield ClO2 minus. We need to add on reduction reactions to the left. We're going to add our electron. So it went from a +4 to a +3, so it gained 1 electron. So we're going to add 1 electron to the left. So this was step number 2, writing the half reactions, including the electrons. Step 3 is balancing by mass. So anything except oxygen and hydrogen. So I'm going to do the oxidation first. Anything except oxygen and hydrogen, well, that's all I have, right? Any oxygens, we're going to add water. So I have 2 oxygens on the left, 2 on the right. We're good. Awesome. If I need hydrogen, add H+. Well, I got 2 hydrogens on the left, so that means I need to add 2 hydrogens on the right. Normally, I'd be done. If this was an acidic solution, I'd be good. But since we're in a basic solution, we will not have any hydrogen ions floating around, right? Because that's acid. We need to have base. So in order to get rid of these hydrogen ions, we have to add OH. So we had 2 H pluses, so we need to add 2 OHs to both sides. Because if I add 2 OH over here, I also have to add 2 OH to the other side. Because that will balance. What happens then if I have 2 H pluses and 2 OHs, this overall gives me 2 waters. So now I have 2 waters on the right. So technically that goes away. So now this should be balanced for mass. So let's double check. I have 2 oxygens. I have 4 oxygens, another 2, right? So I got 4 oxygens on the left. I got 2 oxygens and 2 more. I got 4 on the right. I have 2 hydrogens, so 4, and then 4 hydrogens. So I'm good. So that's part 3. Let me do the second one. So step 1, or 3A, balance anything other than hydrogen and oxygen, so our chlorines are good. B is add H2O where we need oxygen. So, oh, look at that. We don't even need to balance oxygen. That looks good. We don't need hydrogen. We don't need, oh, look at that. That was nice and simple. We didn't even have to do anything. Step 4 is balance the charge. So let's make sure our charge balances. So on the left, we have a 2 minus charge. On the right, we only have a 1 minus charge. So that means we need to put a 2 here. We really need 2 electrons here. Because we have 2 minuses on the left, we have now 2 minuses on the right. So then, let's do the bottom one. We have a 1 minus on the left. We have a 1 minus on the right. So that looks good overall. Okay, so we balance with charge by adjusting electrons. Then we need to add our half reactions together. Well, if this half reaction has 2 electrons, this half reaction only has 1. So we need to multiply this bottom reaction by 2. So we're at 2 electrons plus 2 ClO2s yields 2 ClO2 minuses. So now we are balanced there. So overall, if we add these reactions together, right, I guess I could write them out again. So our oxidation, we got 2OH plus H2O2 yields O2 plus 2 electrons plus 2 waters. That was our oxidation reaction. Our reduction reaction is 2 electrons plus 2 ClO2s yields 2 ClO2 minuses. We're going to add these two together. We're going to cross out anything that is the same on both sides. So the only thing I see that's the same on both sides are the 2 electrons. So if I cross those out, I should get 2OH minuses plus H2O2 plus 2 ClO2 should yield O2 plus 2 waters plus 2 ClO2 minuses. So this should be balanced now. Let's double check. Let's double check our oxygen, hydrogen, and chlorine. We're also going to check our charge. So this should be our answer here. Let's double check. So we're going to count our atoms. So over here we have 2 oxygens. We have another 2 oxygens. And we have 4 more oxygens. So overall we have 8 oxygens on the left. Let's do the right. We got 2 plus 2 plus 4. So we're also at 8 oxygens. Hydrogen, it looks like we have 2 on the left. Oh, I missed those 2. And another 2 over there. So overall we have 4. Over here we also have 4. Chlorine, looks like we got 2 on the left. Over here we got 2 on the right. Check our charge. So we have 2 negative charges. So we got a -2 on the left. We have a -2 on the right. So this is our answer here. That should be your answer.